May the 5th or something like that. It's to
The 9th, is it the Wednesday or is it the Monday?
a Wednesday or Monday, something like that.
I think it's Wednesday.
Okay, so let's start. So the last two topics of this course, first one deals with conic sections. So these are not functions. They are conic sections. They are two functions in one. But the bottom line is they're not functions. The first one that we would look at is in section 1.8, and we skipped it when we looked at it. And it's about a circle. Now we understand that a circle, if I want to graph a circle, let's say this is, bear with me and say this is a circle. Is this a function?
No.
No. So if you want, this is one function, and here's the other. So it's two functions. But we're not going to look at it as two functions, per se. If we want to graph it, we have a way. We have to plug in two different functions because the calculator will not allow us. But there is another feature, which is the conics feature, that will allow us to graph that. Okay? Good. So let me take you back to the distance between 2 points first. So let's say I have 2 points. Here is point A and here's point B. And I would like to be able to determine the distance between these two. And you could say, you were talking about the circle, and now you're jumping to this. Bear with me, I'm getting to the circle, promise. Point A is the first point, so I'm going to call it x1, y1. And point B, I'm going to say it's x2, y2. Because it's the second point, and it has coordinates x2, comma y2. Okay, I'm going to form a right triangle, of course. And I'm going to call the distance between A and B, the D. And I'm going to ask you to give me the length of this leg. And I'm going to ask you to give me the length of this leg. Because I want to be able to write d squared equals the first leg squared plus the other leg squared. So, what is the measure of this? And what is the measure of this? Say it again. Very good. Indeed. So this is x2 and this is x1. So this must be x2 minus x1. Very good. Awesome. What about the other leg?
y2 minus y1.
Very good. This must be y2 minus y1. So then we have the distance squared, which is x2 minus x1, everything squared, plus y2 minus y1, everything squared. Yes, we normally don't like this formula as is. We take the square root from both sides because we want the distance. However, here's a question for you before we continue. Can I simplify this in any way, shape, or form?
No.
Absolutely not. It was a trick question, of course. Nope, this is it. We cannot simplify a square root of a sum. We can simplify a square root of a product or a ratio, but not a sum or a difference. So this is it. And this is a distance formula. We did this a long time ago. That part we did. I'm having the same difficulty. Okay. Okay. So perfect. So now bear with me, and let's go back to the following graph. And let's say this is a circle. And here's the center of this circle. And the coordinates of the circle are h comma k. And I'm going to say that this is a point A on the circle of coordinates x comma y. Of course, x and y have to verify the equation of the circle because the point is on the circle. I'm hoping that you would agree that the distance between A and C is the same with the radius of the circle. And I would like you to dictate this equation using the notation we have now.
Sorry, what was the square root of?
Yes, but this one with the not with the square root.
Oh.
It's the same. It's the same, but I prefer this one. You'll see in a minute why.
Yeah, and x minus h squared
Yes, x minus h everything squared.
plus
Yes,
y minus k squared equals r squared.
that's it. This is the equation of a circle. This is the equation of a circle. And how did we get it? From the distance formula, in which we replace the distance between the 2 points, center and the point on the circle. So we replace them. We replace in the formula the distance and the coordinates of the circle. Good. There are 3 different types of problems that we need to look at when it comes to the equation of a circle. Here's the first type, type 1. In type 1, we are given the center, -3, 4, and the radius, 2. Please create the equation, or give us the equation of the circle with the center at -3, 4, and the radius of 2. I'm ready when you are.
Do you want to say 2 squared or 4?
You have to say 4.
4.
Yeah.
4 equals parentheses x plus 3 squared plus y minus 4 squared.
This is the equation of the circle with the center at -3, 4, and the radius of 2. Here's how I graph it. Let's say I'm asked to graph. Here's how I do it. I start with this by plotting the center. -3, 4. 1, 2, 3, 1, 2, 3, 4. Right here. I create 4 points. All of them have to be at an equal distance from the center. And one of them will be north, one of them will be east, one of them will be west, one of them will be south, exactly 2 units away from the center. So 2 units away will be here, 2 units away will be here, 2 units away will be here, and 2 units away will be here. And now I connect those points. So this is the graph of the circle, centered at -3, 4 with a radius of 2. I'm going back to section 1.8 to select from there and those problems are on page 92. I'm lying. They are on page 94. Sorry. Okay, so now here's an equation. I would like you to identify the center and the radius for this circle. By the way, is this a circle? Is this the
Yes.
equation of a circle? Yes. So please give us the center.
X at 2, y at 0. Radius is 3.
That's it. And now we have to choose, and please choose on page 94 any problem from 103 through 108. (103) through 108.
Six.
106. So we have x squared plus y squared plus 1/2 x plus 2y and plus 1/16 equals 0.
106.
So, I'm sorry?
What a question. 106. Number 106. Okay. What page is this? 94.
Okay, so let's discuss what the problem is asking because we haven't discussed that yet. We only copied the problem. We're given an equation and we're asked, is this the equation of a circle? So if we just pick this problem, so Joey said, okay, 106, and I'm looking at this equation and my answer is I have no clue. I have some work to do before I say yes or no. But at this point in time, I'll say I have no idea. It could be. As long as I can present this equation like this, in which there is a completed square with x, and there is a completed square with y, and there is a positive number on the other side, not 0, of course, then I will say yes. But if I'm not capable of arranging this like this, then I will say no. That is not the equation of a circle. Could be something else. Okay, so obviously I have to start by completing the square for x. And I see this, and I see this, and I'm thinking of complete the square. If you remember a long time ago when we talked about complete the square, I said it's not a method for solving quadratic equations.
Right.
Because it alone will not solve the equation. I have to take the square root. So I complete the square and then I look at it and I say, what do I do now, right? I have to use a different method. So complete the square alone does not solve the equation.
Right.
But the complete the square is for this and for the other conic sections that I will present to you. So that's why we learned complete the square. So middle coefficient is 1/2. We divide 1/2 by 2, we get 1/4. We square 1/4. Ah, I already have it. I'm not going to edit. So now these three terms are here. Here where? What's in here?
X plus
Very good.
1/4.
Exactly. Exactly. Let's do this again. First term squared. Remember, this was the first day of classes. First term squared plus 2 times the first times the second plus the second term squared. Awesome. Plus. So now I'm done with this. And now I have to work on these two. So I see y squared and I see 2y. Middle coefficient 2 divided by 2, 1. Square 1, I get 1. So I will have to add 1 to both sides. And now 1, 2, 3 are here. And this is the only number left on the right-hand side. So what do I have in here that will, when I square them, which terms, such that when I square them, I get y squared plus 2y plus 1. Very good. So now I'm at this point in time, I am capable of answering the question. Does this represent the equation of a circle?
Yep.
Yes, because I was able to rearrange those terms and show it in the form of an equation of a circle. And now I have to identify the center and the radius.
-1/4 and -1.
Very good. Awesome. And the radius?
1.
That's it. Yes, we waited for 3 months to see this usefulness of completing the square. Good. Let's choose another. That was it. That's why we needed to complete the square. And for the other conic sections, for the ellipse and the hyperbola. Okay?
How about 108?
108. Very good. Good pick. 3x squared plus 3y squared plus 6x minus y equals 0. Okay. Now this is a slightly more difficult situation. Can anyone say why? By comparison to the previous one.
It's a leading
Exactly. So let's write this note again. I don't remember if we wrote it or not, but even if we did, it's okay if we write it again. Note. I must have a leading coefficient of 1 when completing the square. Always. It's a must. I can complete the square.
That's backwards.
Good. So then what do I have to do first?
Back 3.
Even more than that. Although 3 is not a common factor to all terms, I must divide by it in this case.
Okay.
So I will divide both sides by 3. So then I have x squared plus y squared plus 2x minus 1/3 y equals 0. I have no choice. Good. Again, I have the same question here. Is this the equation of a circle? And the answer is I have no clue. Wait till I do my work and then I'll tell you. So I am going to say, okay, I see 2 terms with x. What will I have to add to both sides?
1.
The coefficient divided by 2. I get 1. 1 squared, I get 1. Good. So then, what do we have as the completed square for x?
X plus 1.
Very good. Now I turn my head to y. So I have this, and I have this, and I need to add something to both sides. The middle coefficient is -1/3. When I divide a fraction by 2, it's like multiplying it by 1/2. It's easier to think in terms of multiplying a fraction by 1/2 when I want to divide it by 2.
1/6.
1/6. And now I have to square 1/6.
1/36.
Very good. Very good. So then plus, I have something squared. And then on the other side, I have 1 plus 1 over 36. So what is the completed square for y? All about. Y minus
6.
1 over 6. Because that's what we squared to get 1 over 36.
Right.
So it's 1 over 36. Okay, very good. So then the right-hand side will be 37 over 36. And the left-hand side, x plus 1 squared, y minus 1/6 squared. And now if you ask me, I'll say yes. This is the equation of a circle centered at
-1.
very good. And the radius 37 over
6.
that's it. Don't ask me to graph this because I'll have some difficulty with the radius. And also plotting negative 1/6. I'll have terrible difficulty with that too. Any questions? Any questions? Everything okay? Yes? No? Joe, you had a question?
I guess I'm a little lost on completing the square.
Which one?
I don't understand completing the square
Okay.
completely.
Okay.
It's like when we get 5 minus 1/6. I'm just trying to think, what do I think of?
Okay.
To do it?
So we have this y squared minus 1/3 y, right?
Yeah.
So forget about the problem. I just need to add a quantity and subtract the same quantity. Because otherwise, I change the problem, right?
Yeah.
So it's like I'm giving you $10 and I take it back. So plus 10 minus 10 didn't make any difference.
Right.
First, I have to identify the middle coefficient. So this has to be in descending order. So I had negative 1/3. Second step is I have to divide this number by 2.
Okay.
So when I divide a fraction by 2, I think in terms of multiplying it by 1/2.
And that's where you
So that's negative 1/6. Because negative 1 over 3 divided by 2 over 1 is negative 1 over 3 times 1 over 2, which gives us negative 1/6.
Right.
Then I have to square this, and I get 1 over 36.
And that's what you have both sides.
And this is what I add and subtract, or it's the same as saying I add and subtract or add to both sides, because this goes to the other side.
Okay.
So now these 3 are here. Oh,
That's the one.
say it again.
I was saying, why is it a plus 136 instead of minus?
It can never be a minus. I will never be able to complete the square. The third term in a minus b squared or a plus b squared is always positive. Right? Remember from the contract. So a plus b squared or a minus b squared, the last term, we don't even discuss it. It's always positive. And when I square negative 1/6, I have to get 1 over 36.
Yes.
Right?
Yeah.
Okay, so then minus 1 over 36. And this is the on the other side. Is this better?
Mhm. Yeah, makes sense.
Okay.
So we're just trying to rewrite that to like a squared plus b plus c, right?
You mean this?
Yeah, when we complete the square.
Yes. So I'm using these with 1 to to get the completed square. And then I have to have the -1 that is actually on the other side. I have to add to both sides, or I add and subtract. But if I put it plus and minus, then I have to move it to the other side anyway.
Right.
Is this good enough or not? You want to choose another, or?
Yeah, just like the fraction is, it's a weird fraction.
So the problem was 1/6.
Yeah.
So the middle coefficient is -1/3, and then I have to divide it by 2, and I get this. And then I have to square this, and I get 1/36. So now the first term squared minus 2 times y times 1/6 is this, plus this squared is this, and this one is this. So first term squared minus 2 times the first times the second, plus the second term squared. Better?
Yeah.
We need to choose another, or we move on? Okay, so let's choose another. Which one?
(107)
107 to x squared plus 2y squared minus 3x. 2x squared plus 2y squared minus 3x equals 0. 107. You want to work on this for 1 minute? Okay.
Yeah.
So what will you do first in this problem?
Divide by 2 from both sides to get an equal coefficient of 1.
Very good. Mandatory. We cannot complete the square.
And then complete the square for x.
And what will that be? I have to add to both sides, or add and subtract, which is the same thing.
Right. So, divide -3/2 by 2.
By 2, or multiply it by 1/2.
Right. And multiply.
So this will be 3/4.
Right.
When I square 3/4, I get,
Nice.
that's it. One more time, is it clear how we got the 9/16?
Yep, I understand it now.
So the middle coefficient -3/2, because it's a fraction, in my head I say I'm multiplying it by 1/2 because it's easier to calculate.
Right.
So it's 3/4 or -3/4. Then I have to square -3/4, so it's 9/16. And now these 3 are here. And then plus y squared and equals 9/16. So what will you write? So these 3 have to be here.
X minus 3/4
That's it.
squared.
Since there is no term with y
It's just like y.
is just y squared. It's already complete.
Yeah.
Good. So now I can identify the center and the radius.
So the center is 3/4 and 0, and the radius is 9/16.
Careful.
Square root
Yes.
9/16. Oh yeah, yeah. So yeah, 3/4.
Good. Okay. So let's go to chapter 11 now. So now I would like to list the conics. There are 4 that we're going to look at. So total conics. Circle, which we just finished. The ellipse, that I will continue with. The hyperbola, we will continue with that. And the last one, parabola. And you can say not again. Well, it's not the parabola you're thinking of. It's included. That one is included too. But it's mainly this. Although we are going to look again at the parabola with different eyes. So it will include this, and it will also include this, but we are going to find new things about it. But yes, this is a function. This is a function. But the circle, the ellipse, and the hyperbola, and this type of parabola are not functions.
Right.
So 1, 2, 3, 4 are not functions. This one, yes, it is a function. As we know, we don't change. So only the circle is done. We know how to graph it. We know how to identify the circle, the radius, and the center. We know how to manipulate an equation and check whether it represents the equation of a circle or not, using completing the square. Okay, so now let's continue with the ellipse. An ellipse is something that kind of resembles a circle, but it's not a circle. E is a number between 0 and 1. If E is 0, not to be confused with the Euler's number. Okay, so please do not confuse this particular E with Euler's number. So if you have your book, it's on page 737. It's called the eccentricity. The eccentricity of an ellipse. If E is 0, in other words, no eccentricity, that is a circle. If E is as close as possible to 1, okay, which it cannot really be 1. So I'm going to say, instead of that, I'm going to say close to 1. Close to 1. The more away from the circle the ellipse looks like. Okay? So as different as possible from a circle, right? So if the ellipse is close to 0, if the eccentricity is close to 0, then we are really looking at a circle. There is no eccentricity. In other words, no ellipse. If E is close to 1, then the further away from a circle the ellipse is. Okay? First of all, what is the ellipse? How do I construct an ellipse? Okay? I'm getting to my prop. Here's my prop. And they're assuming that there are 2 points that are fixed. So here there are 2 points that are fixed, and I'm going to connect them here. And I'm going to do this. And that's how I construct an ellipse. Okay? Yep. So any point on the ellipse, can be found at the constant distance from these 2 points called foci.
Okay.
So this point here has the sum of the distances to the foci identical with this point here. So any point on the ellipse, so let's say I'm going to say this is F1 and this is F2 for foci, F1 and F2. So, and here is a point on the ellipse. This distance to point 1, the sum of these 2 distances, this plus this, will be identical with the sum of this plus this. Any point on the ellipse. So the sum of the distances between any point on the ellipse and the foci is a constant. So the distance, or the sum of the distances between the foci and any point on the ellipse, any point on the ellipse. So the sum of the distances between any point and the foci is constant. So we know now that the ellipse has 2 foci, and it has a major axis and a minor axis. So I'm going to graph an ellipse again on the x-axis, and I can graph it on the y-axis. Let me graph it on the y-axis this time. I'm going to say 1, 2, 3, 4, 1, 2, 3, 4, and it's going to be centered at the origin. So here's my graph. This is the graph of an ellipse centered at the origin. And having, so this is 4, -4, -2, and 2. Major axis between -4 and 4. On the y-axis between -4 and 4. What will you say about the minor axis? Yes, between, so on the x-axis between -2 and 2. Now let's write the equation of this ellipse. And here it is. X squared, y squared, we'll fill in the rest together.
F1, F2.
Nope. So under x squared, I have to have this distance, half of the minor x's in this case, squared. What is this distance?
2.
For the y-axis now, under the y, I will have this distance squared. That's it. Mandatory 1 on the right-hand side. How do I determine the eccentricity? The eccentricity is calculated as C divided by A. And you can say, what is A, what is C? Yes. A the two forms of the equation of the ellipse are x squared over a squared plus y squared over b squared equals 1. And the other one with x squared over b squared plus y squared over a squared equals 1. I don't like the way the book presents it because I don't want you to have to memorize that if A is bigger, then I have to put it under X, and if B is bigger, I have to put it under Y. No. So I would like you to remember is that no matter how the ellipse looks like, the corresponding numbers underneath depend on the major axis or the minor axis, depending on whether, in this case, the ellipse that I picked is an ellipse that has the major axis on the y-axis. So then this number must be 16. Yes, if this number is bigger, because let's suppose we don't have the graph. How will I know how to graph this? Well, it's not a big deal because it's going to be up to 4 and down to -4. And it will be left to -2 and right to +2. So I know exactly that the major axis will be on the y-axis. Or the major axis is vertical. Okay. So we will get back to this. I'll explain in a second which one it is. But also C has to be determined as a squared minus b squared. Okay. Now, obviously, C is a number. It has to be a positive number. So you can say, which one is A and which one is B? It doesn't matter. This number has to be positive. So this must be the bigger of the two. There's no two ways around it. The C I have to be able to take the square root to get C. If I'm not able to get the square root to get C, then I know that I plugged in the wrong sequence. We'll get to examples right now and we'll see it. It's not any problem. Okay, on page 739, let's practice the ellipse. I like to start with problem 12, and then you choose the next one. 12 on 739. So I have 4x squared plus 25y squared equals 100. So they are asking us a lot of questions, but first of all, let's look at this ellipse and decide. Well, I said already it's an ellipse, but how do I know? What do I have to do first? Exactly. This is the key. If I don't have 1 here, nothing matters. So if I can form the 1 here, then there is no ellipse. So absolutely the first step, I have to divide both sides by 100. So 4x squared divided by 100 plus 25y squared divided by 100 equals 1. Now I have to simplify those numbers because I still don't know yet whether the major axis is on the x-axis or on the y-axis, and I cannot answer their questions yet. So I'll simplify 4 and 100 by 4, and I get 25 in the denominator. And I simplify 25, and I get 4. Now I know exactly where is the major axis and how long it is. So the equation is x squared over 25 plus y squared over 4 equals 1. This is what is called the a squared, and this is what is called the b squared.
So if it's under the x squared term, then
Then if it's
then
longer,
it's on
yes,
the x-axis.
yes, because
Okay.
a is 5, which means -5 to +5.
But whatever number's under the x term is on the x-axis.
Yes.
And vice versa.
Yes.
Y.
But it depends on which one is bigger.
Yeah.
Since this one is bigger, which means a will be 5,
Yeah.
and this one will be b equals 2, then I know -5, 5, and -2, 2. So I can already say that the center of this ellipse is 0, 0. And I can graph it if I want to. And I can answer the rest of the questions. So -5, 5. And 2, 2. How long is the major axis? How long is the minor axis?
Okay, so. Okay, explain that again. So
The length here is 10 and the length here is 4.
Yes, but I guess I wrote maybe correctly, but when you were saying that the major axis was on the y-axis, that was for the other example.
Yes, because this number was bigger than this number.
Okay, so the larger number decides what the major axis is going to be.
Sure, because you have more stretch in that direction.
Okay. So,
Now we have to find that number c, which is the square root of a squared minus b squared, assuming that this is the correct order. A squared is bigger and b squared is smaller. So this is the square root of 25 minus 4, which is the square of 21. I have determined c for 2 reasons. One, c will gives the eccentricity. And the other reason why we need to find c is to find, so gives the coordinates of the foci, f1 and f2. f1 in this case, with a major axis on the x-axis, f1 has coordinates minus c comma 0. f2 has coordinates c comma 0.
How do you get the center?
It's the origin. These are not shifted yet. We're going to get. So if we change this into x minus 1 squared and
Oh, gotcha.
yes,
Okay.
right. So if you remember for the circle, so this was shifted to the left 1/4
Yeah.
and up 1 as the center.
Alright, so there's no values.
Yes.
Oh, okay.
Since they are not yet, not till the last section of this chapter, we're not going to look at shifted conics. So first we establish what this ellipse looks like, and we learn a few things about it, and then the hyperbola, and then the parabola, and then I'm going to throw at you all sorts of combinations.
They all can't just be 0, 0.
No. No. Nope. Because we can have something like this. And this will be a shifted conic, a shifted ellipse, left and up. Okay, so coming back here, we want to identify the foci. So negative c, we determined it. So how much is the square root of 21? 4 point what? Square root of 21, roughly 4.6. Okay, so 1, 2, 3, 4.6. So 1, 2, 3.46. So this is F1 and this is F2.
Can you move the paper up a little bit? How did you get the 2 points? Is that just a standard?
Yes, negative c comma 0 and positive c comma 0. I like the summary in the book, but sometimes it is the summaries are a little bit confusing. You find them on 734. So they do present parallel the two possibilities, but I don't like the fact that they switch these. Well, they switch these because they want to stay with a squared minus b squared at all times, which is fine.
Okay.
Okay, so if a is bigger, if this number under y squared is bigger than the axis, like I just gave you the previous example, it's on the y-axis. If this number is bigger, then of course it's on the x-axis. It's not a big deal.
Yeah.
As long as you remember, the bigger the number, that's where the axis is.
Yeah.
And of course, the foci on the y-axis, the coordinates will be 0, comma c and 0, comma negative c.
Yeah, right.
On the x-axis, they have to be negative c, comma 0 and c, comma 0 because they are on the x-axis. Okay, so let's see if we answered and what we answered so far. So one more time, I will write that F1 is negative the square root of 21, comma 0, and F2, the coordinates of the other foci, is positive the square root of 21, comma 0. Focus, the other focus. Okay, find the vertices. Okay, we found the vertices because we already graphed the function, the ellipse. So one vertex, if you want, is negative 5, 0. The other one, 5, 0. 0, negative 2, and 0, 2.
What about the eccentricity?
Okay, yes. So we determined the foci, and now the eccentricity of the ellipse. So the eccentricity of the ellipse, c divided by a. We have c. Where a is always the bigger number. So this was the square root of 21 divided by 5. Always remember, it cannot be greater than 1. It cannot be less than 0, of course. Okay, so I punch it in. So the square root of 21. And I divide that by 5. So it's 0.9165 approximately. Which is quite close to 1, which is quite far from being a circle.
Right.
Yes. Sorry, Steve.
Would you be able to graph it with the eccentricity being greater than 1? Would you even be able to, would we get
No,
this
the
far?
eccentricity is a ratio.
Okay.
And it will never be more than 1. So the eccentricity is not even 1. So E is only between 0 and 1. And it's always C divided by the bigger of those two numbers. In this case, it's going to be divided by 5, not by 2. That's number 1. And C is always the square root of the quantity the bigger quantity squared minus the smaller quantity squared.
Okay.
Good.
So you know you did something wrong, and if you do, in your
If the
calculation-
eccentricity is more than
Right.
1, there is something wrong. Definitely. Absolutely. Yes. And I like this. So the eccentricity close to 0. Very difficult to see whether it's a circle or an ellipse, right?
Yeah.
Mhm.
And this is 0.1. 0.5, 0.68, 0.86. The closer we get to 1, the more away from a circle the ellipse is. Good. So let's look at other problems, please. Please choose. That's all about the ellipse. Choose any problem you want. 9 through 22, 23 through 28, 33 through 44. I like 45 and 40 through 47. Those problems, I don't think that were selected by my department, but those problems have application in Calc 1.
Hmm.
So we should do one of those as well. But before we do that, just choose.
Like the graphs.
You want to look at graphs?
Yeah.
Okay, which one?
26.
26 it is. In 26 we have I'm going to copy what I see. And I see a 4 up here, which definitely means a negative 4 down here. And I see this point and this point, and I am told I see here that this is f 0, 3.